Hi, my name's Aniket, and I'm going to present on what we at KPF learned after creating 1.2 billion Revit curtain panels. Our agenda is loosely going to be this, where we're going to start with things about what is KPF and why am I presenting on Revit curtain panels or curtain panels in general. We'll talk about the decision matrix for curtain panels. We'll talk about Rhino Inside and its implementation. We'll talk about facade system case studies at KPF. I know you guys are all here to really listen to those and to really look at the cool projects that we at KPF deliver. And then we're going to talk about the essential concepts to remember and then the general resources. So we at KPF generally are known for our large-scale projects ranging from super tall buildings to master plans. And our practice is spread across 9 different offices across the world, ranging from Seoul being our eastmost office to San Francisco being our westmost. Our headquarters is in New York, and we also have a large office in London, helping with our European operations. As we were talking about how KPF generally is known for their tall buildings, we currently boast 6 of the 11 tallest completed buildings worldwide. And even though we are known for our super talls, we also have a fair bit of other kind of architecture, ranging from education to hospitality to office spaces to mixed-use spaces and master planning under our belt, which is generally the case with any firm that is almost 50 years old. We at KPF also have a large design technology team, which can be divided into 7 different segments, ranging from computation, BIM, visualization, digital fabrication, urban interface, and environmental performance and data science. And then we also have 2 different bands kind of spanning across all of these 7 segments, out of which I am part of software development, but embedded inside of BIM. We also, since are a big team, we leverage a lot of the design technology and we're actively researching and implementing it. If we are not able to find it on the market, we're potentially just developing it in-house. As we talked about, the BIM team operates across the 3 different time zones, ranging from New York, London to Singapore. I'm based out of London, but I work globally with all 3 of these teams, helping them automate the boring stuff and help them alleviate the tedious and the quantitative tasks that they have to deal with. And more often than not, you can find me developing an add-in for one of these 3 time zones. About me. So I graduated with a master's degree in architecture and urban design at Columbia University in New York. And I was working as an architecture designer until I realized that my true passion really lies in digital design and moved to KPF as a computational BIM specialist. What does that computational BIM specialist do? So a computational BIM specialist works with curtain panels, hence the reason presenting. We also interact fairly a lot with Grasshopper, Dynamo, Rhino, Revit, basically all the buzzwords that you deal with or you've listened to. I would create these streamlined design processes to help translate Rhino geometry to Revit, vice versa, create Revit panels, so on and so forth. Until a year ago, when I was promoted to software developer at KPF Design Technology, where I create innovative applications to improve and streamline design processes for not just the higher leadership, but also architects on a daily basis. So talking about panelization, as you can see, we have a lot of unique and interesting panelizations, and this only constitutes around 10% of the fun curtain panels that the BIM teams across KPF have built in the last 1 year. So you can see we deal with a lot of curtain panels, not inside of Revit as well as in the real world. And you can see one of our projects kind of going through from an early mossing stage to being made completely out of adaptive panels that were 8, 12, and 16 point. We're going to talk about that as we reach the case study part of the presentation. So now comes the curtain panels decision matrix. So the curtain panel decision matrix is something that we at the KPF BIM came up with to help us understand how are we going to tackle these curtain panels and how best we can deliver them. So when we get a massing, one of the first few things that we're generally looking for is the structure very monolithic or is it more unitized? And instead of the monolithic, if it is monolithic, can it be divided and taken a look at as you're adding to the solid or you're removing from the solid? What we've realized is we can use void. What we have realized is if you use voids very intelligently, you can deliver very interesting, complicated geometry fairly easily just by following that process. So inside of solids, obviously, is there a single material or are there multiple materials? And we're going to go through each of these examples as a case study. When we go through the case study segment of the presentation, this is just to give you an idea of how we're thinking about curtain panels and if it's unitized, is it a facade, is it slanted, is the skill level high, is it extreme? For example, 10, 20 Hudson Yards is a relatively high skill level process, but one Vanderbilt is a fairly more extreme complicated building. And we can talk about this again in the case studies. Comes to vertical, is the panel flat, curved? If it's curved, is it complex? Is it simple complex? Is it really, really complex? Talking about simple and complex. The divisions for the flat panel is there a pattern? If there is none, is there a length? If there is, then is the mullion single? Is it patterned? Is it unique? And then obviously there's an example of these. You guys are going to get access to this presentation, and then we're going to cover each of these in the case study as we reach. So basically the idea is that we can divide the curtain panels into 3 different segments, and these 3 different segments or ways of creation are system panels, custom mullion, custom panel, and the third one is adaptive panels, which is the really fun part of dealing with it. And the other things that is kind of important to know is you can use interoperability, kind of like Dynamo and Rhino inside, as well to help create these panels. So not just something that you need to create from scratch. And for us to understand interoperability, let's go to the next slide. So interop is obviously great resource because you don't have to start from scratch whenever you have something already molded inside of Rhino or your other design authoring software. So the interop evolution at KPF has been an interesting one where we kind of started with linking .sat files and generic models for complicated pieces of geometry that we generally don't need to document or provide more details for. And from there on, we went into the wall and roof by face on a linked generic model. Obviously, post Revit 2022, Autodesk has kind of given us the ability of linking .3D files directly inside of Revit. It's kind of buggy, but it works in most of the situations. And then obviously the age-old way of creating geometry using Rhino, Grasshopper, CSV, Dynamo, Revit approach. And we're going to talk about it in a second. And then until this really revolutionary idea came of Rhino inside, which we at KPF love and use a lot of. And then there was another thing that kind of developed independently of Rhino inside, but is really useful as a single quick solution is Beams and Block. So it's a third-party add-in. It's a single quick solution. Click on the Rhino geometry, put that into Revit really easily, works most of the times. But we at KPF like Rhino inside more because most of our projects are already being designed in Grasshopper. So we can just take that geometry from Grasshopper and put that into Revit using Rhino inside fairly easily, not that complicated. Now, the part that I really think that everybody joined this presentation for was the case studies at KPF. So obviously we're going to start with something really simple. One of our more simple projects, well, complicated geometry-wise, but really cheeky in the way how we dealt with it, is Hongqiang East A3. So the challenges for this project were that there were a lot of double curved surfaces. There were varying profiles along extrusion. There was a lot of single material, and the mass was being generated in Rhino without Grasshopper. So you can imagine how difficult it would have been to kind of deal with it. But also the geometry was being updated on a daily basis, if not hourly. So the part that we kind of suggested was to use sat links with Revit, and you can see that that sat link ingested inside of a generic model. You can see how clearly it cuts and how cleanly it cuts. So it's a fairly easy product to. So you can see how this is something you can use on a project to deliver really complicated facades. The next in line is Changjiang Center in Wuhan. Fairly simple-ish projects. We used loadable curtain wall families. There were multiple materials in vision area. There was a continuous mullion with multiple materials, varying floor-to-floor heights with fixed spandrel, and there were faceted corner condition. One of the themes that you'll see across KPF projects is there's always going to be interesting, complicated corner conditions, which will never be consistent. So we always have to deal with corners in a more innovative manner. 10 plus 30 Hudson Yards, again, one of our trademark projects that have kind of redefined the skyline in Manhattan, in New York. Loadable curtain wall families is how we dealt with this project. There was multiple materials in the vision area. There were angled panels, not just horizontally, but also vertically. There were varying floor-to-floor heights with fixed spandrels, and there were mitered corner conditions. By using this method of loading curtain families and kind of slanting them, you can see how clean the wall type drawing or the wall type 3D looks on the left corner. Next comes the Hangshan East A3. This is a fairly another cheeky way of dealing with it. So we used system curtain wall families. The issues were single material for vision area, the single material for mullion, the varying radii of each panels. And then what we did was we embedded the walls inside of the system panel. And this came as a solution from one of our teams where they realized that if you embed a wall inside of a system panel and you change the material of the wall to be gloss, the wall will follow the curvature of the curtain wall, which means that it's a pretty clean cut when it comes to a curtain wall. When we were given this problem, our first solution was obviously we're going to solve it with adaptive panels because it's, complicated tools lead to complicated methods. But when the team suggested this, we're like, wow, this is awesome. You can basically resolve this using something much simpler and less complicated than than adaptive panels, which we'll take a look in a second, how complicated they can get. And then the other project that has kind of redefined and has made sure that KPF pops up. The other project that has redefined how KPF The other project by KPF that has redefined the Manhattan skyline is One Vanderbilt, again located very, very close to the Chrysler Building as well as the Empire State Building. Our obvious way of resolving this was using adaptive panels, and we used 4-point adaptive panels. The facade was angled vertically as well as horizontally. There were mitered corners, there were varying materials per panel, and there were repeating components. The next project is 2000 Bell Street, talking about acute corners and complicated corners. So we used loadable families, and we also leveraged run inside for dealing with the piers. So we had to first deal with angled corner conditions, which would change. So we had to make sure we came up with a system where all of these corners that would align together would need to get updated on a matter of minutes if they were changed. And obviously, hence we used trigonometry. So all a designer needed to put was the angle between the two walls inside of the panels, and the corners would automatically join for both of the panels, which is pretty brilliant. And then came our second issue, which was the placement of the piers. So the piers that you guys can see on the facade would sometimes change as is a lot of architectural design. They would go from the repeating patterns of AB to ABC, and they needed to be updated. And it was a fairly tedious process. So we leveraged Rhino Inside to kind of place the panel, and we tied that to an Excel. So a designer could update the panel however they want inside of an Excel, and this would read from the Excel and just update it on the facade. And this cut down the update time for the piers and the curtain panels from like a day down to 30 minutes at max. One of the more complicated projects that we delivered in China called Base Lake 66, bunch of 6 buildings, very complicated. They had really complex geometry inside of the panels, multiple materials for the frame. The design for all of these were done inside of Grasshopper. The combination of curved and straight panels and repeating elements inside of the panels. The general complexity of this was that this started pre-Rhino Inside. So we had to take the Grasshopper that was being developed and then input that Grasshopper and export a CSV out of it, then take that CSV, do that into Dynamo, take that Dynamo, and then run that into Revit. So it was all in all a fairly heavy and expensive task to run, where it would sometimes take a day to update the 6 buildings. While if this was done using Rhino Inside, it would very easily take like 3 hours or 2 hours at max to do it. So really fun, really complicated project. This was still 4-point panels. And we'll talk about fairly more complicated panels and in the upcoming examples. And obviously we use trigonometry for calculating a lot of the panels. So mathematics, as you can see, an underlying theme is fairly important. TCC Hangzhou is the first KPF project that uses Rhino Inside for these panels, and we'll talk about it in a second. So you can see how it's a mix of vertical and horizontal panels. The walls are slanting. There are 9,500 plus unique sizes and transom heights. It's a mix of curved and straight panels and the minor mullion conditions. The form was completely generated in Grasshopper. So this, I would imagine, is just not possible to deliver in any other way inside of Revit. And you can see how clean the adaptive panels look on the left wall type drawing, or wall type AXO. And it's just not possible. Like if we don't have Rhino Inside, it would be fairly hard to deliver this. Portfolio Auto Center, one of the newer Rhino Inside projects that we delivered. There were a lot of the panels, well, I think all the panels in this were doubly curved panels. We were using Rhino Inside to transfer geometry from Rhino to Revit during the concept phase. The form is generated 100% in Grasshopper, and it was all responsive to different movements. So we had these pipelines built where you would change something in Grasshopper. Once you freeze it, Revit will automatically update. And the adaptive panels were placed in Revit using Rhino Inside. It's a combination of 8, 12, and 16 adaptive, 16-point adaptive panels. So it's a relatively small building, but it has a lot more complexity than a lot of the larger buildings that KPF design. But you can see how clean, again, the theme is. If it's mathematically possible, then Revit's going to be easy. And you can see how clean the wall type axonometrics look on the left, which are the blowouts of the larger tower on the right and the mini tower on the right as well. Project Libra, another one of our fun towers that we designed, confidential. Again, as you can see, the theme is truly doubly curved panels. Form was 100% generated inside of Grasshopper. The adaptive panels were placed in Revit using Rhino Inside, and the piers were created using Rhino Inside as well. And it's a combination of 8 and 12 panels, because even though it looks faceted, but it's technically not. And the reason we generally start using 8 and 12-point panels instead of 4 and 6-point panels is because of the tendency of adaptive panels inside of Revit to flip. And if you do an 8 and 12-point panel, what this allows you to do is basically have the back edge of the panel as well. So you can define that. And once you define that, the panel doesn't flip. So at that point, it's very consistent and constant. And that means that also Revit's doing less of the thinking for you. You're doing more of the thinking for Revit, so it's going to place it faster. Project Aquarius, another one of our fun doubly curved towers. So truly doubly curved panels, 100% generated in Grasshopper. The adaptive panels are placed in Revit using Rhino inside, a combination of 8 and 12-point panels. And then the idea is vector mathematics to resolve top trim and panel intersection, which is very important because if you look at this edge, if you do not have that kind of defined, if you don't know vector mathematics, then you can't understand how the panel is going to dip when the trim kind of cuts it. So now comes the more fun concepts that you need to remember when it comes to curtain panels. The first is flex it and move it. It's important that you flex the panel once you create it. If you don't flex it, if you don't move it, it might just break in production, and it's going to be much harder to see what's breaking in production versus when it's breaking inside of the family design space. The other thing is you generally never design a curtain panel for the 95% or a curtain panel family for the 95% of the cases that it works. You technically should design it for the 5% of the cases where it might fail. So you have to take into account those edge. Really important thing is to know your mathematics, know your maths. Trigonometry, really important as a concept. Vector mathematics, Pythagoras theorem, geometry. A lot of the times, a person who's going to be resolving these really complicated curtain panels are going to be sharing these expressions. So don't look at them weird. They're probably just trying to figure out how to deal with the top adaptive panel. Embrace the interoperability. So Revit, Rhino, Grasshopper, all working in the same space. Really important. The idea is you should be able to visualize what your Rhino and what your Revit kind of looks like in the same space at the same time to make the least amount of mistakes and make sure your data is constant and consistent throughout the process. Next is to always break into the smaller problems. So take a really large problem like a facade, don't try to solve it, all of it in one go. Try to break it into much smaller problems. Try to break those problems into much smaller problems. Try to solve those really tiny problems, the lowest hanging fruit. You're probably going to get to the really high problems really fast. And also the harder problems are going to look very easy because you probably have the base for a lot of the easier problems from when you solve them. Talking about the resources, obviously the biggest resource that I can talk about is Aussie BIM Guru and his presentation or his learning video for adaptive facade panels in Revit for Al Bahar, the triangular ones. A great resource. If you kind of like my voice, myself and a colleague of mine at KPF also did a presentation on creating adaptive panels and how to work with them in an efficient way for AEC Tech UK, so you can find them on YouTube. And then a great resource if you're trying to dip your hands into interoperability is the Dynamo and Grasshopper for Revit book by Marcelo. Brilliant resource. That is pretty much it for me. Happy BIMing and thank you. If you have any questions, let me know.